Okay, so I wanted to go over something that a lot of people might not be aware of, and this could easily affect the sound quality of things, or at least it's an interesting thing to note. You kind of think of Wi-Fi as being this signal that's always in the air, and in reality, that's not actually true. So what I've got set up here is I've got an access point, and I've got the spectrum analyzer sitting on an antenna on it. As you can see now, I've got this set for channel 1, and we're just looking at the spectrum of that channel. So that's the transmitted spectrum coming out of this Aruba right at the moment. But this is held, so this is all peak. So what I'm going to do is I'm going to go ahead and do clear right. Now what this is showing what's really going on. So what's really going on is as it does stuff, it's sending out pulses. So the signal is not constant like what you would think. You know, I can set this to hold all that, and then as we go, we begin to see the actual spectrum appear. But in reality, it's really very bursty. What's really occurring is very bursty. You can also see that over here. What I'm doing over here is I'm powering this through one of my supplies, and I'm feeding it like 14 volts, and it's drawing like 380 milliamps. But what I'm looking at on the scope is the current. So this is the power that it's drawing. And you can see that when it transmits, it's drawing more power. And what we're looking at here is what's called the beacon interval. A Wi-Fi access point constantly transmits that at whatever rate you set it at. In this case, I've got it set at 100 milliseconds, which this is 20 milliseconds per division, so that's 20, 40, 60, 80, that's 100 right there, and you can see it right on the edges. So that's the beacon interval. And in between there, you can see it transmit actual data. So you can see that what's being bursted out of this is really quite bursty. It's not a steady state signal. You know, and so this all matches with, you know, what you see coming out of it in RF. So what I'm going to do now is I'm going to use another iPad I've got, and I'm going to run a speed test on it. So I'm going to max out this channel. So you can see what it's doing right now. It's just doing some background in the beacon. So I'm going to go ahead and start the test. You'll see it start. Receiving data. It's now receiving data. So it's using the whole channel width. And the amount of current it's using gets a little stranger and higher. And then what happens is we're going to get around to transmitting data. Transmitting data is actually quite different in the amount of noise that it's generating from a power supply standpoint. So it's doing very different things depending upon what's going on. So why is this important to audio? Well, what happens is this RF that's coming out of here in this bursty manner, audio gear is not going to receive this 2 gigahertz signal. But what it could do is it could induce a DC voltage or lower frequency currents as it saturates these interconnects and these circuits that weren't designed for this 2 gigahertz signal. So what could happen is it could modulate what's going on the gear and on the signals by this low frequency bursty rate. So, you know, if you've got stuff going on like what I'm doing there, which is just simply browsing stuff, and then I'm going to run a speed test. This is going to cause very different amounts of RF in very bursty manners to come out of this unit, or come out of any Wi-Fi. So this could modulate, this bursty manner of modulation could create noise and modulation on your audio frequency lines. So there's a whole different other reason why, and this is all really low frequency stuff. So and this has a lot of bandwidth, a lot of weird stuff that goes with all this bursty stuff. That's really interesting. So I think that's really what could affect audio, is not the actual RF itself, but the effects of the RF. So as it's hitting the interconnects and the grounding and the cases and all the various stuff in the gear, what's really happening here is it's modulating that with noise, with kind of thumps and kind of stuff that's going on, and that's causing other issues. This weird bursty stuff also could overwhelm, things with CPUs and digital gear. It could overwhelm stuff that's got all sorts of things. So this type of bursty stuff is probably what's really going on, that we see, and how it could affect audio gear, is this kind of bursty mess. So yeah, so it's not, it's definitely, Wi-Fi is not this, not this pretty signal that we all think it is, of just being, one, I'm letting it accumulate it, of being a nice simple spectrum like that. What it really is it's a really complex bursty pattern that's going on. So anyway, I wanted to explain that. I'm not sure, so what you really want is you want less of the bursty pattern, but you can't really do much about that. But the less data you have going over it, the lower the rates, all of that might make a difference. It also might be that a higher speed rate might be better, because then it won't burst as much to get the same amount of data through. So it's these are all interesting observations at this point.